anthropogenic sources. Okay, and in this particular aspect or perspective, this is due to human activity. So it could be caused by the mainly from the environmental pollution or pollutants that derive from the our activity, okay, from human activity or our activities that we conducted on Earth. Okay, for instance, if environmental pollution from the factory, okay, these are all because we want to produce products, okay, so we have to make a factory in order to support the demand, okay, and eventually we release CO2 or release certain metals to in the form of ions and in the form of gas, okay, towards the environment, and eventually it will go to the soil, okay, due to rain, okay, due to accidental release or directly released to the environment and so on and so forth. Okay, this could happen, and it will add up the concentration of the metals in the soil. Okay, so when we talk about the anthropogenic sources of metal contamination, this can be divided to 5 main groups. Okay, the first one is metalliferous, okay, mining and smelting. Okay, these are okay. I have to say that this part is very important for your exam. Okay, so please take note on that. Okay, so metalliferous, because I've completed your exam paper already. So this is, if I'm asking, this is one of the questions that I'm asking in the final exam. So you just have to take note on this. Okay, so metalliferous mining and smelting. Okay, the metals that can be found from these activities, arsenic, cadmium, lead, and mercury. From industry, arsenic, cadmium to zinc. You can read that this thing. Okay? And then atmospheric deposition from arsenic to uranium. Even this one, uranium, we know that mercury is a very dangerous heavy metal. Uranium is much more dangerous because it is radioactive isotopes. Okay, isotope. And then we have agriculture. Okay, we have to do agriculture, and this is one of my project with hydroplants never had. Okay, I'm producing the microbes for biofertilizer. So agriculture activities can produce or can incorporate arsenic, cadmium, copper, zinc, even uranium into the soil. And last but not least, waste disposal, which include arsenic, mercury, zinc, okay, can be deposited in the soil, and these are the anthropogenic sources or cause of the metal contamination. Okay, so I've put the notes on that. What is smelting? Smelting is actually the extraction of metal from its ore. Ore ni kalau bahasa Melayu dia biji besi, biji timah, biji arsenic, biji cadmium, contoh ore biji, by a process involving heating and melting. Okay, so for instance, tin smelting, this one is actually extraction of the tin. Tin is biji timah dalam bahasa Melayu. Okay, and the process is smelting. Okay, and then source of metals from weathering of mineral rock sources. Okay, so this one I had mentioned to you here, the anthropogenic behavior from the Greek meaning man-made. Okay, is the human activity that has effects on biophysical environment. Okay, so it can these are all the processes that could incorporate the metals in the soil. Okay, and then we talk about weathering. Okay, weathering, as I did mention earlier in the second or third slide just now. So weathering is the breaking down, okay, of earth rock. Could be rock, it could be soils, and it could be minerals through direct contact with the planet's atmosphere. So source of metal from anthropogenic sources. Okay, these are actually the sources of metals from anthropogenic sources. Okay, and then it could be in the form of mechanical or physical weathering. Okay, involves the breakdown of soils, rocks into small fragments through direct contact with atmospheric conditions such as heat. Okay, as I did mention here, solar heat, water, ice, and pressure, without changing the rock's mineral composition. And it could be in the form of chemical weathering, whereby the chemical weathering can be defined as the alteration of the rocks into new minerals. So from the one type of mineral into another type of minerals. Okay. Okay, so here are the examples of the physical weathering. So if you can see these the pictures here on the left side and also on the right side. So we talk about the left side first. This one you can see that this is actually a natural arch, okay, that is being produced by erosion. So you can see the hole here, and we can see the arch there on the other side of this particular rock, and the hole is in between, okay, of these two. One it's a big boulder of rock, and the other one is in the form of arch. Okay, so this one is produced by erosion and of differentially weathered rock in Jebel Kharas. Jebel is a mountain Kharas in Jordan. Okay, so you can see the example of weathering. So the weathering part, which part of it is that caused the weathering? I mean, that is affected by the weathering is the middle part that is hollow, with hole. So the rocks here has been gone, or has been fall down to the soil down there due to differential weather rock. So the weather effects towards this rock is different from the left side and so than the right side. So and because of that, some part of this particular boulder has been lost, okay, through this weathering process and broken down into small pieces and fall on the soil at the bottom part of this boulder. Okay, all right. Then we have this on the right side, a rock in Sweden. Okay, the place name is Abisko. You can see the fracture. Okay, this boulder has a big fracture at the center part. Okay, along the existing joints. Okay, so and this could be by frost weathering. Okay, when the frost because we know that Sweden is a four-season country, right? So it has all the four seasons: summer, winter, okay, spring, and also autumn. Okay, so what happened here? Okay, during the autumn and so winter, the rock, okay, or this boulder shrinken, okay, because of the coldness, and when summer happened, okay, the thermal heat or thermal stress start to expand this particular rock or this particular boulder, and when this processes happens, okay, happen many times or happen frequently throughout the year, and eventually it will lead to this particular fracture. So you can see that the fracture uh, is so fine, okay, until the point that we can see most of the fracture line is actually a straight line. Okay, so it's a fine fracture, right? And then next, okay, this one on the left side, Typhony at Salt Point State Park, Sonoma County, California. Okay, so this is called as Typhony, and this happened at Salt Point State Park. Okay, and then on the right side, okay, the surface pattern on this pedestal rock is honeycomb weathering. So you can see something like honeycomb is happening on the surface of the rock, caused by salt crystallization, and this happened in Yale, Taiwan. Okay, so imagine, okay, on the left side and also the right side, okay, almost about the same, but this one we call as Stephanie, and the other one is honeycomb weathering. So the hollow part, okay, within that is being confined by the edges of the Typhony, and also the edges of the honeycomb. So the hollow part has been fall to the soil. Okay, for both cases, the inner part, okay, of the rock has been degraded, okay, or has been weathered, and eventually break and fall towards the soil down at the beneath part of this particular boulders, okay, and eventually it will add up to the concentration of elements or heavy metal elements on the soil. Okay, we can see also salt weathering of building stone on the island of Gozo, Malta. So something like that. Salt. This is due to the salt weathering. And then we can see salt weathering of sandstone near Kurdistan, Azerbaijan. Okay, so this is salt weathering. And the Permian sandstone wall near Sedona, Arizona, USA, has weathered into a small alcove. Okay, so the structure that you can see, the hollow structure within this particular